So, hello everyone. And on this note, I know that some of you have been in this room for a bit of time to see our conversations, but I just want to formally present Carlos Castillo to you. He is a local product owner on SOC verification in Nokia. He explained it in very simple terms, saying that he's a team lead. But I think we really need to ask Carlos to actually explain what he's doing and what all of these abbreviations mean. Because as for me, I'm not an engineering student, so I have no idea what it means. So please, Carlos, could you please explain us what your responsibilities are and who you are?
Yeah, so um, like you say, I'm Carlos. I'm a LPO, so meaning local product owner. I'm leading the validation team of the radio module of the 5G base stations. So my role is to validate that the system on chip that is that radio module, um, it is working properly. And what is that radio module? The radio module is the intelligence, is the brain of the whole base station. So it's where all the data is processed. So for example, if you have 200 people using the same base station, uh, that radio module is the one who is processing that data. So I think in this meeting, I want to express and I want to dig a bit deep into the engineering point of view, because many times we talk about 5G and you only know the concept like 5G, but many people don't know what is actually 5G and what is the difference between 5G and the previous generations. So I will talk about a bit of this as well. And if you have any questions about what is a radio module, then I think at the end you can, or a system on chip, I can talk a bit more deeply. So what is really 5G, and what is the difference between 5G and the previous 4G? So the main difference is the frequency where they can operate. Sorry, I could hear some echo. So these frequencies is a really limited resource. It's a physical resource, and usually is owned by the government. Those frequencies range are shared between multiple phone operators, meaning that, so for example, two phone operators will be working more or less in the same frequency range, trying not to collide with each other. They will build their own cellular networks, and there they can transmit all the data that they want. Usually, these cellular networks are also public. It's from the public information, but they never tell the real truth. So it is not always perfect, and there will always come interferences between different different operators. But this interference is not happening only between operators. It can also happen due to the environment where this signal is being transmitted. So if there's a lot of buildings and you have an antenna behind a building, then your reception, your coverage will be really, really low. So all these different behaviors of the signal, it's caused by mainly because of the frequency that they are using. So what is actually a frequency? So a frequency is the time where the signal gets repeated itself, right? So for example, this signal, you have two hills here from 0 to 2 pi, and then it can be repeated again from 2 pi to 4 pi, right? So that is the wavelength. And then the amount of repetitions that you can have in one period is the frequency, right? So for example, as a really, really easy example, how many bits of information we can transmit? So imagine that in this signal, this top point, we are transmitting a 1. And in this bottom point, we are transmitting a 0, right? So we can send 2 symbols every period. Okay, so let's say that this is a 4G signal and it's working in 1 gigahertz. So in 1 gigahertz, we can send 2 symbols every period. Now, let's take the 5G example. 5G example will go from 3.4 gigahertz onward. So it means that it's at least 3 times, the frequency is at least 3 times bigger than in the 4G. So if we follow the previous example that we're transmitting a 1 up here and a 0 down here, then you can see that in 2 pi periods, we can send 3 times more data than it was happening on 4G. So every 2 pi, we can send much more data. So why do we use 5G and why do we use this frequency onwards? Because the greater the frequency, the greater the capacity that we can send. So more data can be transmitted at the same time. And this is from 3.4, but it can reach until 27 gigahertz right now. That is in the standard of 5G. So it will be 30 times more capacity than the 4G. But what is the drawback? Why we were using these wide wavelengths before? Because if we have this wide wavelength and we put something, I don't know, like I said before, maybe some building in here, the 4G, it will get interference, but it will not be totally lost. You could get some coverage. But when we go from 3 gigahertz onwards up to 30 gigahertz, even a hand can be a blocker for that signal. So that's why before we were using really low frequency, and now due to this new generation, we will start to go from 3 gigahertz onwards, because now we have found the solution on how we can use this tiny signal with this high signal in a much better way. So if we move to the old solution, so the old solution, the antennas, usually they were radiating everywhere, right? You could be with one phone, you are not using the phone, but still the antenna is transmitting to your phone. Like, hey, are you here? Are you available for me? And then what this means is that we are losing a lot of power. The antenna is constantly transmitting, everybody's getting radiation, everybody's getting data that it's not useful for you. And you cannot predict anything. You don't want to predict anything. You don't want to, it doesn't matter. You transmit everywhere, that's it. But if we move to high frequencies, also we can, and we avoid to have a building in between your antenna and your device that you want to receive. Then what we can use is to lower the power of the signal, and we can direct the beam directly to your device. And then this comes up, there's a new term that is massive MIMO antennas. That means that you have multiple inputs and multiple outputs. And this is due because these signals are so small, we can build smaller antennas. So now we will have hundreds of antennas, mini antennas in one of these array. While before we had only one big antenna just transmitting everything. Now we'll have like hundreds of antennas that can and has the opportunity to create beamforming. So only this device will be getting the radiation. Only this device will be getting the data. And these devices, they will be idle. And then, for example, if this device gets activated, then only this device will get the data. So thanks to this, we are removing other interferences. Now we don't care how many antennas your competitor has and how is it going, because you know that your users, they will have high coverage everywhere that they are moving, because the antenna can follow what they are doing. The antenna can predict where is it going, and it will radiate only to that place. So actually your competitor can have in the same cell another antenna transmitting, and your users will not be ruin their coverage because of that. But what was the real target of 5G? I have to say that the real target of 5G was not common users. It was not you and me. The real target of the 5G was Industry 4.0. Why? Because now that it allows to have such a high density of devices, we can implement an environment where we have millions of IoT devices. We have millions of, or we have tens of autonomous vehicles transmitting data. And we can have so much capacity in there that it doesn't matter that we can stream 10 YouTube videos from one device and the signal will still be good. So one use case that it comes quite easy for me is the mining. Why? Because it's a high risk environment. And it's an environment that it will have thousands or if not millions of devices connected at the same time. And the security and the safety of this environment has to be 100%. So for example, if there is a human controlling this underground mine, whenever something is happening in this underground mine, until the control can reach and can have that knowledge, if there is a human, then it will take maybe the best case scenario will be tens, hundreds of seconds until something happens, and we are putting some humans' lives in risk. But if, for example, we have IoT devices in this underground mine, that, for example, a pipe is broken, the IoT can sense that there is some leak, it will transmit to the antenna, and then the antenna will transmit, thanks to 5G in a really low latency, to the control. Control can shut down that gate. The mine is not flooded, and lives can be spared. For example, let's say that there is the open pit, and the load is all the rocks are going up, and then that loads can tell the control, like in 30 seconds I will be up, be ready. So the truck can come, be ready, be in their position. The load can be carried by the truck, and the truck can start moving. These trucks actually can be autonomous vehicles because they will have a point A to point B, and these autonomous vehicles can be controlled or can be controlled from a human in there without being inside the truck. So these trucks can start going, and they can start asking, what is the status of the train? Is the train full or is not full? Where do they have to go? Maybe the train can say, I'm full, don't come here because I'm departing now. So the trucks can continue the path and try to deliver to the boat, or simply wait until there is a new order for them. Also, these trucks, what can do is that they can feel that there is some human in the middle or some container, and they can recognize if it is a human or a container. All these use cases can be enabled thanks to 5G, because we can transmit a lot of data. We can transmit really high capacity. So for example, if it's an autonomous vehicle, we can constantly stream the video that this truck is happening in a few milliseconds. And then it will be really safe, self-organizing, and quite many use cases can be enabled after this. But this doesn't happen only in mines, it can happen also in factories. So the factories can be more productive if we'll have all these IoT devices contacting each other. or power plants. So if the network it's going down of the power, we can react quickly and not leave a city without power. Or even in farming, and the use cases are infinite, and this is actually the target for the 5G, why the 5G was thought. But of course, we cannot leave the users alone, and we need to keep the users happy, because actually they are the ones who will be bringing money to the telecom. So thanks to this, we will start deploying 5G antennas everywhere. And from some use cases that I can think is to have gaming. So thanks to the 5G and the low latency, it will be actually better to use 5G than to use Wi-Fi, for example, in a really crowded environment. Or, for example, augmented reality. So you can go in the street or with your car, and you can play with augmented reality from that car. It can show you some possible humans coming to your way or something. And the best case scenario will be really high dense cities. So you can imagine a city like New York or Tokyo, where there are really high buildings. There is a lot of interference from every other operator. Thanks to the 5G and beamforming, you can actually remove a lot of those interferences and give a better coverage to your users. Another use case that it can help with, and this is also a new thing from the 5G, it's network slicing, meaning that you can have a stadium, it can be a football match, and you will have thousands of spectators there using social media, calling their friends, and sharing all these exciting things that they are seeing in the stadium. And usually, every time that there was a stadium, a football match, or there was a riot, or there was some kind of these events where there is a lot of data traffic coming through, the whole network was going down. So actually, if you are in a house close to a stadium, you might lose coverage because all the people are taking over the network. So with the network slicing, this is a thing introduced by 5G. We can just isolate the stadium, and like this, when you're at home, you don't need to deal with those interruptions. And then I want to introduce that 5G, it is a great technology, but it can even greater if we implement machine learning and artificial intelligence. We always put it machine learning and artificial intelligence, and I want to emphasize that artificial intelligence is nothing without machine learning. We need to, it is actually a subset of artificial intelligence. Also, I want to emphasize that in here, the data is the most important asset. So all these operators, they have a lot of data, and that is why now all our data that is online, it is so valuable for everybody, because without data, we cannot build machine learning and we cannot build artificial intelligence. So how machine learning and artificial intelligence will benefit from 5G networks? So like I said before, we can have this network slicing. So once the network it's getting the information that there is a match going, then artificial intelligence can say like, okay, now I will isolate the stadium from the normal network, and I will queue these requests so everybody can have their fair share of airtime. Then, for example, if some network goes down, it will have a lot of reports. So there will come a lot of tickets to the operators saying like a network is down, or say there is some disruption in this part. So that amount of tickets currently it's held by a team. And with machine learning, what it will happen is that the machine learning can gather all that like some tickets, and it can actually produce an outcome. So for example, if the network is down, machine learning and artificial intelligence can say, okay, that base station is not usable anymore, but your neighbors' base stations can take care of these users. So the network interruption will be slightly 1 minute instead of taking longer than that. Another thing can be risky operations, like in the mining scenario. Thanks to this low latency, we can have the gate shutting down before our mine is flooded with water. Or for example, if the truck suddenly sees something on its path that can be a human or a cat, it can actually recognize there is a human and should stop and should inform the control, like there is a human in a place where it should not be. There is millions of use cases for machine learning and artificial intelligence. These are some few that we are promoting, but you can think of more for sure. So we as a service provider, we have to be leading this industry 4.0. We have to be leading automation, and we have to be leading artificial intelligence. But in Nokia, we know that this is not a big bang solution. There is not a unique solution that you can come, plug some software and say, everything is solved now, carry on. So the first target for automation and artificial intelligence is to remove the repetitive task. So for example, that truck that was going from point A to point B, you can remove a human from there and just take and use the computer to do it. Or for example, an engineer that is in charge of a lab and has to go to the lab, turn off and turn on the power just to reset something. Now you can have automation that if it feels that something is going wrong, it can automatically reset. And like this, we will remove these engineers, we will remove this human from this repetitive task, and they can actually focus on more valuable tasks. And also implementation of automation and artificial intelligence will save in OpEx. So we will have more energy efficiency, we'll have self-organizing stores, we can have maintenance schedule. So we don't need to be constantly checking that. So this will save a lot of money to the industries.
Excuse me, Carlos?
Yes.
Could you please explain what OpEx is?
So this is a operation expense. So it means how much money the industry or your business it's investing on keeping everything running. So how the operation is running.
Cool, thank you.
So I have an example of a real 4.0 industry. I think I will put this at the end of the video of the presentation. I think it will be good. But just for you, as a candy, this is happening already. This Oulu factory, Nokia Oulu factory, is a real industry 4.0. We are fully automated, and we have machine learning and artificial intelligence there. And it is quite cool to see it. And every time I have a chance, I always go to the factory and I can see all these machines working independently. It is really cool. And I was taking a look because I didn't know how I could present this business applied 5G, and I came up with this speech from Risto. He's in the Nokia board of directors, and he's talking about like how to become a high-tech company. To give you the tools doesn't mean that there is the solution already. So like I said before, 5G, machine learning, artificial intelligence can solve your problems, but it cannot solve every problem at once. So how can we become a high-tech company? How any company can become high-tech? So first, you need to invest that your workers know what is machine learning and what can it solve for you. After that, when the workers are seeing repetitive tasks, when they can see that something can be fully automated, then they will ask for the help and how to implement this machine learning, and it will raise this like, hey, can we please have a solution? But they will know what is machine learning. So first we have to apply machine learning internally, and then we can export this knowledge outside. And like I said before, machine learning is nothing without data. And this is something that as a service provider is really crucial for us. We need to start collecting this data from our customers. It is really good to have the data on how people are moving. Like that, we can design better antennas that can predict the movement of the people while they are outside. So, for example, if you are imagine that you are in New York, you are walking through the streets of New York, and you are on the street, you can predict where the human is going to walk next. For example, like, is he going to go straight or is he going to go to the left? And like this, you can produce the beamforming and only radiate to that place. And like this, the human will have a seamless connection to the base station. So all this data, it's in the power of the customer. It's in the power of the operators, of the service operators. So Telefonica, O2, all of these operators. So if we can produce better antennas, then at the end, the users will be the first beneficial for this. And this is something from my side. This is my opinion. And actually, I'm trying to use it in my everyday work. So can 5G fight climate change? So it's not a conspiracy theory anymore, but it can actually be an asset for climate change. Like I said, now we can predict where the user is going to go. We can predict how much power that user will need in order to keep receiving his data. And like this, we can start power saving. Also, like I introduced at the beginning, it is smaller antennas. Due to this high frequency, we can produce smaller antennas. That antenna can be more portable. So now we don't need to have like huge antenna radiating everywhere. Now we can have small antennas just in the places where are needed. And then that huge antenna can be in places that, for example, like really long highway. Then also the self-organizing. So for example, this self-organizing, if the network goes down or there is a high demand in some places, then we can redirect our resources there. Then all the industry will be more efficient, meaning also human resources and physical resources will be more efficient. We will not have this overhead of resources being wasted. And the best thing is that endless of use cases. So you can think of anything and it can happen now. You just need to think of an idea. So for example, in farming, you can have your tractor going by itself and telling, or for example, checking if there is a huge rain coming your way, you can start covering your crops. So there are endless of use cases. That was the presentation. I want to show now the Nokia Oulu factory is a 5 minute video, and I hope you enjoy. Actually have it open. Can you see this? No.
Yes.
The YouTube. Okay.
Welcome to Nokia Oulu factory, or home of radio, as we call it. This is where we produce 5G equipment. Welcome to Nokia Oulu factory, or home of radio, as we call it. This is where we produce 5G equipment, and my name is Erno. Oulu factory is a terrific showcase of our Nokia Digital Automation Cloud, the plug-and-play, industrial-grade digital platform for connectivity and applications. Now let's have a quick overview of the solution.
Here we have a standard industrial facility layout. These dots are your LTE access points that bring connectivity to the whole area, to all your equipment and applications. This is your local edge server, to which the access points connect. The solution has built-in redundancy. Redundancy means that if one part of the digital platform fails, another part takes over automatically and there is no service disruption. The system is not dependent on one access point or edge server.
In our factory, redundancy enables that even the most critical applications can be connected wirelessly, like this testing cell in the modular automation concept line.
LTE covers 85% of today's industrial connectivity use cases. The LTE device ecosystem is standardized too. For extreme capacity and ultra-low latency needs, the upgrade to 5G is easy. Simply install 5G access points and they work seamlessly in your private wireless network. The local edge server can be upgraded with software.
Digital Automation Cloud increases productivity at our factory. We have connected AIVs to the private wireless network, and now they can run without interruptions, which wasn't the case when connected to Wi-Fi.
AIVs enable automated material feed. Our smart buffers send automated requests to the AIVs based on sensors. We can also call the AIVs to the production line when needed by pressing a button that is connected to the private LTE.
Hello there.
Well, hello to you.
Thanks to a fleet manager, the AIVs work in a smart swarm. They are never in each other's way and they share the workload optimally. The AIVs can also monitor the network capacity and coverage in real time.
Digital Automation Cloud is the foundation for building digital twins of your processes. Productivity increases can be verified with a digital model prior to you making any real-world layout changes.
Digital automation enables real-time video analytics. In this case, we are tracking production material quantities. But video analytics can also be applied to production quality control. What comes to connecting production equipment, private wireless allows better flexibility than fixed lines. This way we can easily adapt to rapid changes on the production floor.
Flexibility indeed is one of the reasons to choose wireless connectivity. You can make flexible layout changes in your assembly lines without cabling slowing you down. That brings cost reductions. A wireless network also means less configuration work when you alter the production layout.
In our factory, there are layout changes pretty much every week. Like this line here, it was built up just within days and will be moved to another location after a couple of weeks.
Network slicing enables you to separate traffic from different sources or between different user groups. You can guarantee capacity for priority use and split the network resources accordingly.
Our factory wireless network has the capability to slice the network with different access point names, APNs. We plan to use this feature to separate the production environment from the development environment. We also plan to use this for personal voice or video communication. This way, we can ensure that the production network is always prioritized. Sometimes things can get lost in production. That's why we added the high-accuracy indoor positioning system to give us the real-time position of our assets. Now I know exactly where this lifter is located. It should be clear by now that Digital Automation Cloud brings us real value beyond connectivity. This value comes from the applications I quickly demonstrated, but there's so much more.
Nokia Digital Automation Cloud comes with a catalogue of applications. Some from Nokia, some from existing ecosystems. You can click and deploy applications to realize your digitalization use cases and investments. The applications run locally, thanks to edge computing capability brought by Nokia Digital Automation Cloud.
That's it, folks. I hope you enjoyed our tour of digital automation in Nokia Oulu factory.
So I think I have talked about all those topics before, and now I think you can understand what are those topics. What is network slicing? What can be self-organizing, and how we can save into the resources like that. Presentation is done. I don't know how you want to do the question and answer.
Well, first of all, thank you so much for the presentation. I think it's mind-blowing because I'm quite a geek, and I think everybody in this team is at least a little bit. So it was really interesting to actually see how these things look nowadays, because there's a lot of literature, there's a lot of news going on about how everything is going to look like, but nobody is actually advertising pictures of how, like, oh, there's this factory that's already doing this. So, I mean, I am speechless and I myself have a lot of questions, but I think that we need maybe a 5-minute break, or maybe until 6:20 by the Swedish time, 7:20 by the Finnish time, just so that everybody gets to go to the bathroom, maybe kind of process all of the information, and then we can get deep into the discussion, and I think it's going to last for a really long time. So welcome back, and now we've gotten to a really engaging part of our discussion. Everybody can ask a question to Carlos. We have a really unique opportunity to know everything you want to know about 5G. Basically anything you want to know about Industry 4.0, or maybe Nokia itself. Well, everything that Carlos can answer at this point. I want to ask my question because I have this chance because I'm the mediator, so I can go first. But I think it's a really important issue that this year we saw a lot of conspiracy theories going on. And while sometimes it's funny to talk about, we also know it's quite dangerous. If you can answer this question, could you please tell us about the experience that your company that actually has so much to do with 5G encountered when these rumors and conspiracy theories started going out? So has it actually affected Nokia in terms of business, or maybe there were some obstacles in technological development? Yeah.
Well, luckily, these theories are brought by really small amount of people. So governments and scientists, they know that this is not real, what everything that they are saying. And actually on the other side, there was a group, I remember that those news in UK, there was a group of people burning down antennas. That actually only promotes something good for us, because we can sell more antennas to replace those. So that is the funny way that I took from those news. It doesn't, I mean, you cannot stop 5G, because it will enable more good things that actually we can imagine. So I think 5G and the future generations are unstoppable. So it will happen one way or the other. We cannot live in the past, mainly because our data consumption is every day increasing, and this needs to happen. It's the trend. So you
Well,
cannot stop a moving train.
yeah, I totally get it. And it's a fact that people are not very resilient to change. And I feel like the more high tech and the less understandable the changes, the more resistant people become. And maybe there are some different ideas that come about in the society.
Yeah,
But I
but
hope that
that's
by viewing your talk, maybe some people are going to change their minds.
well, you can see like the first slides that I was presenting. That what was the main difference between 5G and 4G? It just means that the network is more optimized. So actually, it's higher frequency and beamforming. So now not everybody will be radiated. There were those news before when they were building some new antennas next to the schools. All the parents were saying like, now my kids will get some cancer or something like that because it will be more radiation. And actually now with this beamforming capability, we will just be able to focus on the real use case. So we will not radiate to the school, but we will radiate to the street where the people are walking by. So
Yes.
it benefits our environment as well.
I mean, I think that it has to be a bit more vocal so that people actually understand how it works. Because I think that many of these conspiracy issues, they are coming out just because people are misinformed or they are making false judgments because they don't know something or they don't have access to this information.
Yeah,
And
and
we,
I think that it was our problem because we talk about 5G, but we don't explain what is actually 5G in easy way, so everybody can understand that you don't need an engineering degree to understand what is actually 5G.
I think Tish made a really funny comment in the chat. She's asking, so will there be more risks or less risks of cancer because of the higher frequency?
So the frequency um, doesn't generate cancer. What it can or it might happen, it's the power. So the amount of power that is being radiated. So if you're to a really close source of really high power, that can happen something. But like I say, uh, we are living in a society. This is all studied, and actually, you're getting more radiation from the sun that you can get from any of the base stations.
Yeah.
So you should be more concerned about the sun than actually living close to a base station.
Let's maybe move on to some more, not to say serious, all of the questions are serious. Questions that we have in the chat. Lily is asking that there is a lot of talk about 5G and Huawei, and that there is potentially a security issue for Western countries. What is your personal opinion on this?
This is a really hard topic from my side. My personal opinion is, who do you want to share the data with? Do you want to share the data with NSA from US, or do you want to share the data with the Chinese government? So that is something political view. Actually, like I said, Huawei or Nokia, they will not use your data specifically to target you, but in order to improve their services. So that is my personal opinion. We don't care as a service, not as a government, but as a service. We don't care what you are transmitting, but what kind of data you're transmitting. So we don't care what is your picture, but we care that is actually a picture on Instagram. So like this, we can benefit from that information and we can build better services for you. Then the political issue might be how the government state they use that data, but that is something that I really don't know how to answer. But Huawei or Nokia, we will use the data that we have or that information in order to produce better services. Nothing else.
And if we go on a broader scale, Lily is also asking, can 5G be misused? So be it a government, a company, yeah, how can it be misused? Or is it a bit more safe than 4G? Is there a difference?
There is no difference at all. And actually, it doesn't matter if you're using Wi-Fi, 5G. At the end, it's the amount of data that the network it's getting. So you will have all this data. It doesn't matter if you're using an antenna or you're using a fiber connection. That data will arrive to some servers, and those servers will redirect to some other servers until it reaches the destination that it has to reach. So for example, if you are in Finland and I'm sending a Instagram picture so my friends in the US can see it, you can imagine that only the first access to the network is the 5G. But after that, it will be fibers, it will be cables, it will be underwater fiber until reaching the other base station at the other end. So actually 5G, it's the enabler or it's the gate to the network. It is nothing else. So it's how you are going to connect to the network, using 5G or using Wi-Fi. So in that sense, 5G cannot be misused.
Well, to me, all of this sounds very futuristic, although I know that it's happening now, but anything physics related is, I wish I studied physics. But I have a question on a more of a social side. So of course, Industry 4.0, and I'm seeing it from a very, from a perspective of an enthusiast, because I like to study Industry 4.0. My thesis was written on it. And it's nice to think about these positive aspects, about the energy efficiency, about everything that you were talking about. But unfortunately, there hasn't been a lot of consensus when it comes to labor redistribution. And for example, the global north, which is basically the Western European, the the Americas, they can utilize Industry 4.0 and build on the existing technologies. But how is it going to affect the international competition? You know, is it going to create more inequalities between different countries? Is it going to separate us farther from the countries where they don't have the technological competence to actually implement these things? And I just wanted to ask you about the Nokia experience, because I know that I can't ask you these questions. Nobody knows the answers to them. But the Nokia experience, you were saying that you're moving the engineers from the routine tasks to something more value added. And basically, did you end up letting go of a lot of people from the production? So maybe lower skilled workers. Did you end up shrinking your how would you say it, workforce at Nokia?
At Nokia, I don't know about the production part, but at least from the engineering side, every day we're introducing more and more machine learning, artificial intelligence, automation. And I don't see a reduction, but actually we're missing a lot of workforce. So this is something also for all of you. There is a lot of opening positions that you can apply. So I don't see as a reduction of workforce. Maybe the person who was, I don't know, building something, that person is not longer needed to build, but it is needed to maintain or to supervise the machine. So actually that person who has been 20 years building PCB boards, so these microchip boards, now that person will not be fired, but he will be supervising that the work of the machine, it is okay, and the quality is good. So the industry should not fall into laying off the people who are experienced, but they are not longer needed for that task. But the industry should follow to upgrade those persons, to use their experience in order to get more benefit from that. That is my personal opinion.
It's really interesting to hear, because there are so many different theories. There is a group of optimists, there is a group of pessimists, but we don't discuss the real life examples, because there are only a few Industry 4.0 like smart factories that are currently in place, and I don't think they like sharing a lot of stuff that's going on at the moment, just because it's in a very beginning stage.
Yeah.
We have a few more questions in the chat. Joaquin is asking, of the of the use cases targeted to B2C, so basically the final consumers you talked about, which one do you believe or hope will arrive first?
So to the final consumers, I think it will arrive first. This network slicing. So that is a really big topic right now. Also, Ericsson is fighting that way, so it's not only Nokia, and we see a lot of potential in there, and also the beamforming capability. We are putting a lot of investment in the beamforming in order to be more efficient and in order to predict where the person is going to arrive. So only that they will get all the data and all the coverage there.
Yeah.
So beamforming and network slicing, I think is the first use case.
Do you actually know if they have been applied anywhere or only in a testing stage?
For 5G, only testing currently, but soon it will come. I cannot say more, but soon it will come. Quite soon, actually.
Interesting. I think that well, I'm looking forward to it. I just I feel like I'm very excited about leaving and like actually living in these times. We can see that all of these changes are happening. We can compare them to all of these sci-fi movies made in the 80s. Are we gonna see the Blade Runner? Are we gonna see something more optimistic? Who knows? But when it comes to more real life issues, Bart is asking in the chat, is there an issue of cost when it comes to 5G versus 4G? Since 5G can be more easier interrupted by things like buildings, does that mean that if a municipality were to implement 5G to assist in automation, for example, self-driving buses, would that mean they would need to pay more to install and maintain those towers?
That is a really hard question that it should be for the for other teams. So I actually don't know how much does this cost. I really don't know. I don't have that view, but I don't say that it will be paying more to install or maintain. Actually, the current base stations are easily maintained and easily upgraded. So actually, Nokia, this is a public information, did a upgrade in their base stations from 4G to 5G by software. So actually, they did not need to go to the base station, take it down, and put a new one. So someone in the factory or from Nokia can just press a button, and now you have 5G coverage in certain areas.
Yes. I mean, I have no comments because I don't really know what to say to this. But if somebody else wants to contribute to this talk, knows something about 5G, or wants to ask another question, I'm just reminding you that you can do it either in the chat or raise your hand and speak instead of constantly hearing the voice of Carlos or mine for that matter. Tish is saying that Matt wanted to ask something.
At least I think that's his name. Med Yak. He put his hand up and then his camera. Oh, are you there, Med?
Yes, hello.
Okay.
Did you want to ask a question?
Of course, yes. You talk. Hello.
Hello.
Yeah.
Thank you for this wonderful. Are you hearing me?
Yes, we can hear you.
Thank you for this presentation. I have a simple question about. Do you think that the 5G is a good opportunity for Nokia to re-enter the technology rise?
The technology rise.
Yes.
Yeah, actually, Nokia is trying to get ahead. Currently, we are focusing on our most close competitor, that is Ericsson. like everybody knows. And I think we have really good chance now and really good portfolio to be leading this race. So from my point of view, I think we have really good changes. And actually we have, I don't know if you have read, but we changed our CEO. Now it's Pekka Lundmark, and he's coming from Fortum, that it was, that it is energy industry. And he is bringing all that knowledge of Industry 4.0 that he wanted to apply in his own industry into Nokia. So we have really good leverage over the other competitors in this topic.
So good luck.
Thank you.
Mine kind of follows on, I guess. Mine is more about like when I think back to Nokia, you know, I think of like these brick phones and like, you know, and then no one has a Nokia phone nowadays, you know, like if you ask me, I swear it was like near bankruptcy a few years ago. I mean, I don't want to go too deep into sorrow stuff, but yeah, so how did it like make its comeback? And so it's complete. I'm guessing it doesn't make phones anymore, and its sole concentration then is on 5G. And there was also a mention about clouds. Does Nokia have anything to do with the cloud system and all of that?
Actually, if you want to dig into the origins of Nokia, it is a tire company. And actually, you can see in some cars that they are using the Nokia tires. So Nokia is a really good example of how an industry can evolve. And so at the beginning, they were producing boots, they were producing tires. Then they started to get into more like with the operators. So the operators needed to have the cables without being interfered with each other. So Nokia was, because of the knowledge of putting the aluminum in the tires, so to make the tire fit, then they could also put it there. And then they start to investigate on how else they can do. And then they reach and they separate from that tire company to this high-tech company and this operator company. So if you see the history of Nokia from a tire company to a service provider, going through being one of the biggest phone makers in the world, you can see that the industry doesn't have to die, that a company doesn't have to die if it reinvents itself. And of course, now the cloud is our target, because thanks to the cloud, we can decentralize services. So this is a really hot topic right now. So for example, Amazon will start focusing more on their cloud business. So Nokia sees this as an opportunity. So we will not be only like service maker. So we will not only be building antennas anymore, but we have Bell Labs as well doing research, and we will have our cloud organization, and we have our fixed networks. So actually all the fibers as well, so optical fiber and routers and all these servers that they don't use 5G at all, but also Nokia is in charge of that. So we have different companies in that sense. So for example, with the phones, we were not the fastest to change, and that you can see what happened. The phones went down, and now there is Nokia phones, but they are produced by another company that is really close to Nokia, to what is the main core of Nokia, because there were the old engineers from the Nokia phones. They bought back the brand, and they are starting again. So Industry 4.0 is not only about being stuck in the past, but being able to look at the future and go with the trend, be the lead, be a high-tech company.
And so just to follow up, because you mentioned that you were involved in microchips yourself. Yes. So where do microchips come into clouds, antennas?
So for example, this system on chip, this system on chip means a microchip. So actually you have, so your laptop actually has a processor, right? So you can see this Intel Core i5 or i7. That is the whole brain of your laptop. That whole brain also, it is in the base station. Before, we used to have programmable ones. Now we have, so FPGA it was called. Now companies are moving to ASIC. So that allows to be like a real microchip. So you will have a design and you will have a purpose. So you cannot use your laptop microchip and you cannot detach it and put it in your antenna. It will not work. So this is the difference between and why we need to be here, like validating that this actually works, because we need to validate that the purpose of that chip it is fulfilled. So I'm actually coming to this ASIC. Well, this is a really extensive topic, but coming to this ASIC, the ASIC allows to be really tiny. So actually it's 10 nanometer thin, and it's getting even tinier. So I think now, I think Apple, they have released the M1, I think it's called, the system on chip M1, and it's 5 nanometers. So this means that the power consumption will get smaller, and we can actually get the antennas smaller, and we can have more brain power in a smaller piece with less power consumption.
That's really cool, first of all. Second of all, I saw that Alexander posted a question a couple of minutes ago, but Rafsan actually raised his hand, I think 5 minutes ago, and maybe he can ask his question.
Yeah, thank you. Thank you, Carlos, for your very nice presentation. I just have two fundamental questions. The first thing is you talked about MIMO antennas, right, for 5G?
Yes.
I was just wondering, like, how you're distributing the signal or the coverage to the edge devices. How does the signal latch onto the edge devices? That's my first question.
So you need to have a device that it's actually capable of having that technology. And actually, even if you don't have that such device, even if your device is transmitting everywhere, the antenna can recognize where is that coming from, or like it can. So the MIMO, what it is multiple input, multiple output, right? So that means that you can have several people using the same resource. So you can be next to your partner. Your partner can be transmitting, and the antenna will have like two beams, one for you, one for your partner. You will not interfere with each other. So your device actually doesn't need to be MIMO. So for example, my laptop doesn't have that capability, but my router does. So it is only the transmitter side, the one who has to be there, that focus. So that is, the MIMO is that enabler. So really tiny antennas that can have MIMO. So MIMO is really tiny antennas that can have beamforming capability.
I see. And my second question is about the frequency of 5G itself. So you showed us the difference between the 4G and the 5G signals, right? Yeah. So I'm wondering that, so if you keep increasing the frequency to a higher level, how do you maintain the coverage? How do you solve the coverage problem? Because right now there is already 6G in research, and there are talks of 7G as well. So I'm wondering like how you how you work with the frequency to solve the coverage problem.
So going upper the frequency means that anything can be a blocker. So for example, if you're talking in, I think it's 30 to 60 gigahertz, even when you are holding the phone with your hand, the hand can be a blocker of the signal, because that signal is so tiny that your hand can block it. So it is needed a really good study of the environment and where can you place the antennas on the base stations when you are going that high. So for example, if you are going over 30 gigahertz, it is not worth right now to use it for users because the users will block it anyway. So if you are talking and someone will pass through you, then your call can be dropped. So when you go that high, it means that you will have an environment that it will be line of sight. So point to point, there will be nothing in between. And for example, 6G, I see that is terahertz actually. So we have even go one step further from gigahertz. We're going to terahertz. And the use case that I see there is to replace actual cables. So actually it will be much cheaper, for example, in a car, instead of cabling the whole car, by just having an antenna pointed to each other, and the car, like inside all those electrical things will happen through there. So there are more use cases for the 6G. There are more use cases for the high frequencies, like once you reach that level. And so from user point of view, not industry 4.0, but industry, consumer point of view, will be, I think that maximum will be 30 gigahertz. So what 5G is providing already to us.
So I guess you need to do an infrastructural change to adapt to 6G.
Or think what is the real target of 6G.
All right, thank you so much.
Yeah, about 6G, there is right now is the research going on. Now there are all the researchers that are building use cases, and they are trying to find what is the proper solution of that. So it is a really early stage. There is not even a standard about it. So we need to wait a few years until we know what is going to happen with 6G. But Nokia is already looking into 6G. They will have already Bell Labs, so the research part of Nokia, working with 6G and working with the solutions to the possible problems that you are saying.
But
so it was a good question.
Thanks.
Well, first of all, thank you, Rafsan, for active participation. That's the kind of attendees I like. I mean, I like all of the attendees, but I like them especially. I have a small comment about 6G. Actually, even if they come up with a solution from an engineering standpoint, it involves so many different things to actually use it. Like, we have to buy phones that support 5G, in the future, because they are not equipped to, I'm not gonna explain it in the engineering terms. It's just from the point of what we are doing in my studies. And basically there is a complex socio-technical system that's involved, and you need to change all of the different layers. So in addition to finding the solution for these intermissions in the frequencies and these different obstacles that Carlos was talking about, I'm sorry for my terminology, you actually need to adjust the infrastructure, and then you need people to buy the phones that the companies have to develop within a particular span of time that are going to support this new network. And for people to buy the phones, the old phones need to get old. So unless you have enough money, or unless you're an influencer, or this kind of person who wants to buy everything right after it gets released, you're going to wait about 3 to 4 years, on average, before you're actually going to want to renew something. So even if there is like a miraculous discovery about how we can use the highest frequencies or whatever, we are not going to be able to use it just because we're still not there with buying the devices. And we also need to feel the need that I have 5G and it's so fast, and I can post my pictures on Instagram twice as fast, and I get my likes even faster, but we need to feel the need to actually seek new solutions, and 6G and 7G, and update our phones and update our infrastructure and support our government in the fact that we are paying taxes to update this infrastructure, So that's just my bit of input on this.
There is a lot of social studies about this. Actually, operators, they more or less know when the society is ready to come to the new phase, and also they also do a lot of like marketing and so on. So they know when it's the time that the people or like the phones they have a limited life. Yeah. The phones they don't survive forever. First, the makers, they will not make it to last forever. And second, the trend will come. And actually, you don't like to have the Galaxy S1 from 20, like not 10 years ago, right? Galaxy S1, I think was 10 years ago. It was my first smartphone. And of course, you will not have that brick because right now, nothing will work. So if you have any WhatsApp or something, it will not work in that phone. So there is a lot of social studies about that. So maybe you at least are suitable for those companies. So you can give your input there and tell them like, hey, slow down, think about these other people.
I'm not a social scientist though.
No, but what you have said is a bit more of a consumer point of view.
Yeah, for sure. I know that there was this problem when they were moving from the second to the third generation. They failed to convince people and even some companies in the need for 3G. And then they briefly introduced 2.5G. And I didn't even know it existed before I read these articles that we needed for our studies, basically.
Yeah.
We have a question from Alexander. Thank you for patiently waiting. The question is, how much is your unit influenced by Bell Labs? And what is the delay of coming from research to the actual chip implementation?
Sadly, I don't have answer for the second question. He's actually better than me to answer when the 5G was being researched. He's a researcher, I know him. But how my unit is influenced by Bell Labs, actually we're using their solutions in order to make everything happening. So actually my unit is nothing, like we don't know what is beamforming if Bell Labs doesn't research about it and Bell Labs doesn't give us a solution. So Bell Labs has done the research and they have said that in order to have better coverage, we will need beamforming. In order to have beamforming, we will need massive MIMO antennas. You have to build it like this. And they will give us an input on how to build and what to do. So that is the influence. About the delay of coming from research to actual chip implementation, I will say that it's before it was much longer. Now I can see that it's quite fast. So quite fast meaning 5 years from the actual research to the time that we release our product to the customer. So that is really fast, and we are targeting actually to do it in 1 year by the year 2022.